Hello, Algebra 2 students. We're going to keep looking at factoring polynomials completely today, finding all of their zeros, and then we're going to look at one kind of new question type. So the first one is what kind of polynomial is this? Refresh my memory. What do we name it? Pentic or quintic. And 6 terms, so something like that. Yeah, good. Okay. So let's have a look. I think we'll just do this one by what we've been doing all along and start by finding a couple zeros with a graphing calculator. Yep. So you might want to follow along with me. So I think these are a couple special problems I tried to cook up this morning. So there we go. We can see that this polynomial is pretty steep. I might want to expand my window because there might be another zero lurking. How many zeros are we trying to find on this one eventually?
5.
5? Okay, cool. So how many can we see on the graph here?
1.
Looks like 1. But today we're going to emphasize a new issue, which we've seen a little bit before already. That issue is called multiplicity. So we learned that if it didn't just go through like this one does, like if it bounced here, that zero wouldn't just happen once, it would happen twice, or at least an even number of times, right? Now, does this one go straight through like a line right there? Is it going straight through? I don't think so. It's not quite a line. It's like something we saw yesterday, our new parent function, which was a snake, yeah? And what power did the snake have, the first one we investigated anyway?
It's the third power.
It was the third power. It was a cubic, right? If you look at a 5th power, a 7th power, any odd power, it'll have that same shape. But that should tell you something about what's going on here at this zero. Since it looks like a cubic right there, that means that zero probably doesn't just happen once. It doesn't happen twice because it doesn't bounce, but it might happen 3 times. So we can just check that out by doing synthetic division just like we've always done and see if it happens. So let's check it out. So synthetic division, 6. 20, 56, 96, 64. Can you guys help me with the multiplying here? I imagine it's going to be a little bit big. Looks like that zero is at -2. I'm just going to guess because I'll find out if I was wrong quickly here, won't I? So -2, add those up and it's 4, multiply -8, add those up and 12, -24. Is that 32? I think so. And then this is -64, positive 32 again? Oh yeah, nice. Okay, so it was definitely 0 that we're seeing over there on our graph. That confirms it. And then we were thinking, based on this new concept of multiplicity, that the 0, -2 might have a higher multiplicity than just 1. It's probably not 2 because it doesn't bounce, so it might be 3. Let's see if it happens more than one time first, though. So I'll just do it again and see if it works again. If it does, then it happens more than once. -4, 8, -16, 16. Yep, happened again, but we were suspecting not twice because it didn't bounce. We were suspecting 3 times, or at least an odd number of times higher than 1. It could be 5 times, in which case that'd be the only 0 repeated 5 times. It's possible, right? If this was like an expansion, if this guy was x plus 2 to the 5th power, then it would happen 5 times. I don't know if it is. We'd have to look at the binomial expansion, right? So let's see if it happens 3 times at least. Yep. And so let's see what we've got here at this point. It was 5th, here it's 3rd, and here it's squared. So I would just work with this parabola now, and you don't have to worry about your graph. You don't even have to worry if you missed another 0 outside the range of your window or anything like that. Because you've got a nice parabola right here that means x squared, no x, and 8. So I think I'm ready to write this guy's factored form. I'm not going to use the quadratic formula for this guy. To find its zeros, I'm going to solve it by just moving that 8 and taking the square root. So I've got x equals plus or minus the square root of negative 8. You guys tell me what that reduces to?
2i.
There's an I. Square root of 8 isn't 2. It's
2 to 32i.
It's 2 root 2i, plus or minus. Okay, so I'm going to erase everything, just remembering that negative 2 happened 3 times, so I can write my answer down because I'm out of space. So, this guy is exactly equal to x plus 2, because negative 2 is at 0, not just once, but 3 times. And then this guy didn't reduce anymore because it gave us imaginary numbers. So the other factor is x squared plus 8. That is completely factored over the real numbers. And then we usually like to write our zeros as well. So our zeros were negative 2. If you want to emphasize that it happens lots of times, which I think is a good idea, write it 3 times. And then the other factors, the other zeros, excuse me, are 2 roots of 2i and negative 2 root 2i. 5 zeros. There you go. So I think the new thing that we really learned, which we started to work with the other day, was the concept of multiplicity and how that affects the graph. It's going to make it bounce if it happens an even number of times. It's going to make it go through if it happens an odd number of times. And at that local region where you're at, it's going to resemble, if it's third power, a cubic shape, if it's second power, a parabolic shape, etc. Okay? So let's have a look at this one. Now this one I could start the same way, except I think there's an easier way to do this one. I could go and look on my calculator, and that would work. There's a better choice on this one. You definitely want to pick it.
It's a perfect trinomial, so you can just plug it into the trinomial, or the perfect trinomial formula.
I don't know if it's a trinomial because I only see 2 terms. It's a binomial. It's a good idea. Mason's seeing the right thing though. What's he trying to say? Can somebody help him say it? There's something cubic going on here. What is it?
Well, I mean, I know 2 is 2 to the power of 6 and 64.
Oh, so this is 2 to the 6th. Great. This is also something else cubed.
X squared.
What cubed is 64? Think about your power tables. 4 cubed. Now, Carter was totally right. It's also 2 to the 6th. There's different ways to do this problem, but I think the slickest, fastest, easiest way is to go, oh, there's something cubed there, and there's something cubed there. This is a difference of cubes. What's the something cubed here? You guys just said it a moment ago. 4. And what's the something cubed here?
X squared.
It's x squared that's being cubed to give you 6th power. So you can keep that in your head, or you can write it down. It depends what you want to do. But if you recognize that it's cubed in both parts, then you have a difference of cubes. So you can say the difference of cubes formula, we recall, goes first thing squared, first thing, last thing squared, last thing. And can you see binomial stuff in here too? Think about this. See how it descends? 4th power squared, 0. 16, 4, 0 power of 4. This works the same kind of way as that other stuff did. It's because all this math is really just one thing at foundation. It's just which pair of glasses you have on, how much you've done with it. Okay? And then the signs, how do they go? I think if this is minus, then this is minus. And always this formula only has one minus, so that means these must be plus. Now that's the first factoring step. You can do at least one more factor here. Where is it? You should see it. This thing's a little more complex. Maybe this guy factors, maybe it doesn't. But this guy definitely factors, right? That's a difference of squares that we've seen many times. So I at least need to factor that guy. Maybe I'll just leave the other guy alone for now. I've got 3 factors. I can see 2 of the 6 zeros right there. They're very obvious. I don't know if I can see any more zeros from this. This guy might only have complex zeros. I could look at the graph to investigate that again. and that'd be a good option. The other thing I could do is like, this guy almost factors into like something squared. What are the factors of 16 that might work? 4 and 4, are those going to add up to 4? No. 2 and 8? 2 and 8 give you 4 somehow? Try, but I don't think so. 16 and 1? No. So this guy doesn't factor. That means the only other thing that's going to work is the quadratic formula. Now, I'm not going to do the quadratic formula on this one because it's going to be too tough. I didn't give you any problem that worked out that badly. But let's just think about what it would produce. Would it produce imaginary numbers or not? There's a quick way to decide that. Remember, you don't have to do the whole quadratic formula. You just have to look at the what part? The discriminant, right? So let's just do a really quick calculation to decide what this would produce and shortcut our work and move on today, okay? So b squared minus 4ac is the inside discriminant that tells you about what would happen, right? So if I had that here, I'd get 16 for 4 squared. A is 1, and c is 16, so that's 16 minus 48. That's negative 32, but the key is that it's negative, so would I get imaginary numbers here or not? Yes, I would. And since it's
Jessica
fourth
Hasty,
power,
please report back to Ms. England's room. Jessica Hastings to Ms. England's room.
I'm not going to mess with this one with you guys today. You're not going to see anything like that in your assignment to this level. Okay? So let's look at one more question, and we'll call it a day. This one's going to be a little bit new, so it's probably the most important one we're going to look at today. And I know there's 2 of these on your test, so you definitely want to look at a couple. This one today, and 1 or 2 next week. So, third example, we're going to construct a polynomial. So we want to develop, write, construct, however you want to say it, a polynomial that meets some conditions. Our polynomial's got to do these things. So it's got to have the zeros, 6, negative 3. I'm going to say negative 3 has to have a multiplicity of 2. We've talked about what that means. You guys can remind me in a second. And then the last 0 will be 4. That guy's going to have not just a multiplicity of 1, it's going to have a multiplicity of 3. So we want that to happen, and we also need to meet the condition that when we plug 0 in, our y-intercept is 10. Okay? So we'll build this, and then we'll sketch it. We'll see if we did the right thing with our calculator. The idea is you should be able to do this never using your calculator, and I'll make sure the one I put on your test, if you use your calculator, it'll get you into trouble. So you'll have your calculator available with you at home, but it won't help you. Okay? So let's see. If I just want to have certain zeros happen, that's pretty easy to make it happen, isn't it? So since this says f, I'm going to call my polynomial f, and we'll start building it. So, how do I make 6 be a spot that it's 0? I can make a factor, right?
Put it in a transformation form.
Yeah. So go like
X minus 6.
x minus 6. That factor makes 6 be a 0, right? Boom. That makes it happen once. If I want it to happen more times, I could put an exponent. They didn't say anything, so I'm just going to go. All right. So the next one is negative 3, so I want to multiply, right? Times what other factor to make negative 3 happen? X plus 3. This one wasn't just supposed to happen once, it was supposed to happen twice. You could write another one of those, or you could be lazy like me and go boom, because that says it's going to happen twice, right? And then 4 is supposed to happen 3 times, so that's going to be x minus 4 cubed, which means x minus 4, x minus 4, x minus 4. Okay? So I think so far we've made this polynomial happen. We'll check it in a second. Check mark, check mark, check mark. We've got all 3 of those things. And we could expand this, you know, do a Pascal thing here, or do it by hand, do a Pascal thing here, do it by hand, and then finally multiply our results by this. It's going to be gross, so I'm just not going to do it. No way. No, I'm not asking you to do that. It's just a waste of your time. Okay? There's one other condition we needed to meet, though, right? F of 0 was 10. So I want to just put this in my calculator so far and see if it's doing that at least first. So then we'll worry about that y-intercept issue. So I'm going to go in here, take that other one out. I'm going to put in what we built, what we constructed so far. Assume standard. So it's supposed to bounce at -3. Does it look like that might be a bounce? It's really hard to see, and see why. This is why when you're on your test, if you don't know how to use your calculator like a master, if you just sketch this, I'll be like, totally just use their calculator. They don't know what's going on. You know what I'm saying? I think that's what's happening there. And it does go through 4. Does it look kind of snaky through the 4? A tiny bit. It's hard to see though. And then does it go through, it's supposed to go through 6. It looks like it goes straight through 6, right? So does it have a y-intercept of 10 like it's supposed to? Does it look like it? Well, maybe I could change my window a little bit. Let's make it go 50 or something. Oh, you know what? Let's rescale it. Ah, now you can see it a little bit better, right? So changing your window makes this a lot better. Maybe we'll just make it go 100 by 10. So now it's supposed to cross, if we have it done right, at the first tick mark. So I'm going to go that. So it's supposed to cross right here if it's doing what it's supposed to. You can see the bounce, you can see the cubic, you can see the straight through. Check, check, check. It's supposed to do all those things, right? Did it go through right here though? Dang. So how are we going to make that happen? Well, I think we could put any coefficient right here and this would still work, right? I don't think it would have changed what those are. Any stretch factor, any compression factor, thinking like transformations. I'm going to find the exact right one that makes it go through 10. And I'm going to do that by plugging in and solving for this thing, which I've called A. You could call it whatever you want. Call it A because you're used to A. So when I put 0 in, what's supposed to come out? 10. So what comes out goes over here. What goes in the slots where it's supposed to go, right? So what do we have? -6. What do we have here?
3.
Slot 3.
0.
3 squared.
9.
9. And what do we have here? It's -4 cubed, right?
64.
-64. That's a really easy equation. Just got to solve it for A. So you use your calculator, whatever. This could be positive. Can you guys tell me? 6 times 9 times 64. What is that? I don't know. Some big number. I guess
2,456.
So then to solve for A, I just got to divide that to the other side. I don't think you'd guess this in a million years, but I think it's what's going to make it go through the exact right spot if I put it right here. So is it a stretch or a compression that I needed to do to this graph to make it fit and go through right there?
Compression.
It's a big time compression. It's like boom, super smash, right? So I'm just going to insert it, so I have to start over right here. Go 10 divided by 3,456. Let's see if it works. Yep. It's still bounced. It's still snaked through. It's a little harder to see the snake through there. You'd have to cut it down to size a little bit. Maybe go back to 30. This is 10 now, right? Bounce through the spot, snakes through, up through the spot. So I think it's working. Yeah? So, that's how you do a problem like this. You should be able to do this kind of problem without your calculator though, so make sure you are able to, or I will know if you're not. So for instance, before we even did this, going back right here, before I even touched my calculator at all, using just that, I should be able to sketch this graph and know basically what's happening. So I should be able to go over here and say, let me think. It's supposed to go through at 6, at -3 it's supposed to bounce, and at 4 it's supposed to go through and snake. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So -3 it's supposed to bounce. And it's going to go touch that spot at least. At 6 it's supposed to go through. And at 4 it's got a 0 where it snakes through. So I at least have those spots to start drawing my picture. Then I think, what is the end behavior of this function, like we talked about yesterday? You guys remember that? We talked about as x approaches and as y approaches and that kind of stuff. So how do you decide that? Well, you don't have to expand this out to see what the controlling term is. Just think carefully. What's the biggest power you're going to get when you try to multiply this out? What's the biggest power?
X to the third minus 1.
It's going to be this times the first biggest power for this one is going to be x squared, isn't it? So it's going to be x for this one. The biggest thing coming out of there is x squared. And the biggest thing coming out of there is x to the third. So yeah, it's not going to be exactly that or anything, but that's controlling the end behavior. And it's not negative, it's positive. I don't see any negatives that are going to hit that first term. So that's x to the what power?
6.
That's the sixth power. So that tells you the end behavior. If it's sixth power, it works just like a parabola. It goes like this. If it's third power, it works just like a cubic. Yesterday you learned that goes like this. If it's a negative cubic, it goes like this. If it's a negative even power, it goes like this. So that's end behavior, and you definitely need to know all of that. So you want to make sure you get that in the first page of your notes. That's what I'm going to have my class do in just a moment. But for us right now, we decided it's positive and even. So that says the end behavior will be like this. And that allows you to draw the graph. So then you can say, okay, now this is going to have to come down. You guys tell me at this spot, am I bouncing or am I going through? I'm bouncing, right? And I know we already saw this graph, so we're kind of cheating, but that's okay. And then it's supposed to come back and like go through here, right? We made it to go through 10 right there, but whatever. It's going to have to go through or bounce right here. Is it going to go through or bounce at 4 on this one? Through. It's got to go through, but then I should also make it look like what when it goes through? I should like snake it a little bit, so it should probably be like, ugh. And then you know that to connect to that arrow, it's got to like come back up. So this has to work logically, or you did something wrong. So like you know it's got to go through here. And was it supposed to go through at 6? Yeah. It was. And it was just supposed to go straight through. And that's exactly what the graph we got looked like, right? Except I didn't need my calculator to do that at all. And that's a skill you definitely need to have. Give it to you several different spots on the test. And you can use your calculator to check your work, that's totally fine. But if you just use your calculator, I wouldn't. Okay? See you next time.